but couldn't join us. In CodeHS, if you ever want to make your own window, you can click Sandbox. It's up here. And then you can create a new program. I'm just going to call mine String Methods Demo, short for demonstration. I'm going to do Java main is the type of program I want to create, and it'll just pop something in so you can write your own code from kind of from scratch, so to speak. So I've got a little document here with all of notes that I made to myself on the string methods that you're going to be looking at this week. So please, if you have a question, feel free to type it in the chat, or if you want to unmute yourself for a second, you can do that. As long as you don't identify yourself by name, I think it's legal for me to record it, I believe. No video, though. Don't show any video or I have to delete the recording, and that would be sad. Okay, so strings we're looking at this week. Another type of variable, another type of object that you're going to be working with, probably the object you work with the most when you're dealing with Java or most programming languages in general. What is a string? A string is just a sequence of characters. You've been doing them for a while now. You put them inside of quotation marks, and it could be a phrase, it could be a name, it could be a single letter. You could even put a number into quotation marks and have it be a string. Each character has an index. So let's say, for example, if I type out my last name here, and I'm just putting spaces for demonstration purposes. My last name is Foster, and every single letter, every single character inside of a string is indexed, starting at 0. So the index of this F is 0. The index of this O is 1. The index of this S is 2. The index of this T is 3. The index of this E is 4. The index of this R is 5. So what do you do with those indices? We'll talk about it in a little bit, but it's important for you to understand that a string, all of the characters inside of the string, each one of those has its own position, aka an index or like an address, a number that you can call and find that character. So the first character is always going to be indexed at index 0. But since we count the length of the strings just like 1, 2, 3, 4, 5, 6, for example, Foster is 6 characters long, the last character is always going to be the length of the string minus 1. So since Foster is 6 characters long, the index of this R is 5. So those are strings. They do talk about making strings. There's 2 ways you can make a string. You could do, here I'll do first. Just do it this way, which I think we've been making strings that way for a while. And you can create a string object that way in Java because strings are very special. But technically a string is an object, so you could create it by calling the string constructor, which you looked at in the last section. So you could do something like that. There's really not one which way that's preferred. Either one of those ways are okay. In this case, it stores the string Blake inside of the variable first. It stores the string Foster inside of the variable last. But you might see both ways when you're working through the lesson here. So that's kind of the first part, is just what is a string? It's a sequence of characters where each element has its own index. Any questions on that so far? Again, you can either unmute yourself, I think, by holding space, or you could just shove it in the chat. Okay, you keep typing if you got a question or whatever. One thing you're going to be looking at, or the big thing you're going to be looking at, is calling methods on these strings. The thing you looked at last week was just adding strings together, slapping them together with a plus sign. This week you're actually calling methods on them and doing stuff with them. So a quick review of how to call a method. The way that you call a method is you do the name of the object dot name of method, and then in parentheses any required parameters, aka any required values that the method needs. And so again, I highly recommend you have something to write this down on, because there are a lot of different string methods actually in this section. So either take notes right now. I'll share this text file as well, if that, I don't know if that'll help people or not, but I took my own notes and made my own examples, and I'll go through some here. But so just remember, to call a method, you do the name of the object, strings are objects. So in this section, we're going to be doing the name of the string variable, dot, the name of the method you see, and then think about what type of parameters the method requires. Okay, the first method we're going to be looking at is one called charAt, or some people say charAt. Char is short for character. And what charAt does, let's look at it for a second. It requires a single parameter, a single value that's an integer that represents an index. And it returns the single character at that index. So I've written an example here. Let's say we have the string literal saline. Remembering that the first index is 0, this goes 0 for S, A is 1, L is 2, and this I is at index 3. So if I do saline.charAt3, what I'll get back is an I. This is an example of calling it on a string literal. You could just put the string literal inside of quotations. Since that's a string object, you just do dot and then the name of the method here. This number could be anything that's inside of the possible indices for saline. So the possible indices for saline are 0 for S, A for 1, or 1 for A, 2 for L, 3 for I, 4 for N, 5 for E. You can also call it on a variable. So in the next example, I made a variable called city that contains saline, and I did the name of the variable dot charAt. Just making it clear, any of these values you can print. For example, I've printed a value right here. Why does it print E? Because 0, 1, 2, 3, 4, 5 is where the E is located. You can put any of these inside of print statements, like I've done with this, where this is the name of the object, dot, charAt is the name of the method, and then the index I sent it was 5. You could also store it inside of a variable. I could do like string letter equals city.charAt5, and then I could print out or do something with that variable. Let's go ahead and look at an example here inside of CodeHS. Maybe I'll do it with my first name. Maybe I'll do first letter. And I could do first, which is this object that contains the string Blake, dot charAt, that's the name of the method. And we saw that charAt requires a single character. What's going to be the index of this B? Well, we always start counting at 0, so 0. And then I could go ahead and print out that variable. Oh, excuse me. I should have just put inside this print statement. How silly of me. 1 second. That's so embarrassing. Do I look embarrassed? I feel it. Hold on. It's okay. We'll make it through together. There we go. So now if I run the code, I should see letter B. There we go. And, you know, I can put in 2, and I'll see the character at index 2, which is this A. If you didn't think it was going to be A, you probably start counting at 1 for indices. Instead, we always start counting at 0. Why? That's computers love zeros. That's all I can tell you there. So that is charAt. It gives you the single character at an index. Any questions on that one? And again, I'll share this text document. Okay. Some people in the last hour were worried about this like tile that's a little bit loose. If anything lives in the ceiling, it's totally fine. Don't worry about it. All right, next method here. Let's look at another one. Another method is called substring. Substring is used if you just want to take a little snippet of a string. The way the substring method works is, again, you do the name of your string. So it could be first dot or name dot or whatever, dot substring, and then in parentheses you put 2 numbers. One number is the first index, the index of the first character you do want. The second number that you put in after the comma is the index of the first thing you don't want. That's typically how I explain it. Let me add that to my notes. From is the index of the first character you do want, and then 2 is the index of the first character you don't. So as an example, another way to put it, if you're mathematically inclined, you can think of it as being inclusive of from, exclusive of to. So let's do an example here. We've got the string saline again. If you don't want to count out the indices for yourself, this is index 0, this is index 1, this is index 2, this is index 3, and so on and so forth. This says from the first index, the character that we do want is going to be at index 0. So I do want this S in saline. And the first character that I don't want is this 3. So I'm not going to include this I at index 3. And so it just gives me a little chop, a part of the string. I end up getting Sal in this case. The first number is the first thing you do want. The first character you do want. The second number is the first character you don't want. Now keep in mind, it doesn't actually change the variable. It's not going to chop up the string saline. Saline is still as it is. So in this second example, I said the first character I do want is at index 0, this S. The first character I don't want is at index 1, this A. So that's just going to give me the character S. And keep in mind, it doesn't change the string that you're calling it on. So here are two examples of calling it on a string literal. Maybe inside of CodeHS I can show calling it on a variable. So substring example, maybe I'll do it on my last name, which I stored in the variable last. I could do last dot substring, and let's see, maybe I want the OS. Well, where's the O located at? It's at index 1. That's the first thing I do want. The first thing I don't want, if I just want OS, I don't want this T. This T is located at 0, 1, 2, 3. And so now I should see OS. Now, like I said before, it doesn't actually chop up or remove any letters from the variable you call it on. So last still contains Foster. If you don't believe me, I'll just print it out really quick to demonstrate. Why don't you believe me? You should believe me. I know what I'm talking about, despite that error that happened earlier. So there's Foster. So this basically gives you a copy. Now, what else could you do with it? You could store it in a variable. I could do something like this. String part equals, and I could take that little snippet, OS, I could store it inside the string part, and then I could print out part. You'll see that part now contains OS, last still contains Foster, it's unchanged. So that's the substring method. It allows you to take just a snippet. What's that useful for? I don't know. Maybe you're a company that monograms bags or something with people's initials, and they type in their full name, and you chop out the first letter of each one of those. There's a lot of uses, not just monogramming bags and blankets and stuff, but other stuff too. So that's substring. Any questions on substring? Okay. All right. Gravy. Now, you folks have learned about overloading methods. And just a quick review of what an overloaded method is. An overloaded method is a method with the same name that performs a similar operation but takes a different number of parameters. So we looked at those a lot when we were talking about constructors at the beginning of Unit 2. Substring is an example of an overloaded method as well. You see that the previous example we looked at took 2 integers. You can also call substring by just sending it 1 integer. If you only send a single integer to the substring method, it returns a string from and including the character at that index all the way to the end. So if you put 2 numbers, it goes from all the way to 2, not including 2. If you just put a single number, it goes from the character at that index all the way to the end. So as an example, if I call it on saline down here, saline.substring2, let's see what's at index 2, 0, 1, 2. This L is at index 2. And since I've only sent one integer, Java knows to call the substring method that goes from that integer all the way to the end. So if I do saline.substring2, it's going to be line because it goes from that L all the way to the E. I know it's like lean, like saline. I know people in science say saline, but has anybody ever asked if you live in the, has anybody ever mispronounced saline to you? Probably. Okay. I feel like one of those one-man shows where they got the drum and the cymbal and the one-man band thing. Okay. So let's do an example of substring here with just a single parameter. You know what? Maybe I should put comments in here. This is char@. This is substring with 2 params. Let's do substring with 1 param. Not Parmesan, param. So if I do, let's say, I'll do it on my last name here. If I want Oster, I could do the name of the string that contains Foster is last, so I'll do last. You notice that I don't put last in quotes. Why? Because I don't actually want to call substring on the word last. I want to call it on the variable last, which contains Foster. So I do last.substring, name of the object, dot name of the method, and then in parentheses, well, if I want Oster, this O is located at index 1. Remember, the F is at 0, the O is at index 1. So if I just do 1, that should presumably give me Oster. And there you see it. This line of code that I wrote right here corresponds with this output right here, if you're having a hard time matching stuff up. Okay. So that's just an example of overloaded substring. If you put 2 parameters, it goes from the first number all the way to the second number, but not including the second number. If you put a single number, it goes from that index all the way to the end. Questions on substring? I'm sure you guys will probably develop questions and you can always email me. You could set up a one-on-one time on the Google. Well, let's just go over that really quick. I know most of the people in here know how to do that, but just a quick review. On the document that I post every single week, there is a link to a schedule where you can schedule some time. If you click right here, it takes you to several years later after I've discovered internet technology. There you go. It gives you a schedule. And you can click any of those times on Tuesday or Thursday, and I'd love to do some activities with you, work through some of these. That'd be great. But that's how that works. Okay, back to it. Next on my notes, we're cruising. Ooh, index of. This one's a tricky one. But I usually think of index of as it's kind of like the Google search for strings. It allows you to find a string inside of another string, essentially. So the way I've described it is index of, it requires a string that I've titled key. It's essentially the thing you're looking for. It's like your Waldo, if you've ever played Where's Waldo, or the thing you're trying to spy in I Spy. And so you do the name of the string dot index of, and then in parentheses, whatever you're looking for. It returns the index, aka the position, the address, the number where it's located, of the start of the first occurrence of key inside of the string. That's very confusing. Let's look at some examples that might make more sense. If I do saline.index of s, notice I've used 2 string literals here. That's why there's quotations around them. Where is s located in saline? Well, there is an s located at index 0. So I get the number 0 returned to me. You could search for a single letter. It is case sensitive, meaning capitalization matters. If I put a capital S here, I would get a different result. So it searches through saline for S. And the S is at location 0 or index 0. So that's why it's really important that you understand indices. They're just the position of characters inside of strings. You can look for a larger part of a string. You can look for several characters strung together inside of a string. So if you notice, line, L-I-N-E, is located inside of saline. Where does it start? It starts at index 0, 1. This L, the beginning of L-I-N-E, is at index 2. So I get a 2 in that case. Now, index of does only give you the first occurrence of a string. So let's say you have 2 A's in a string, like ABBA has 2 A's in it. If I do ABBA.index of A, you'll notice that it returns 0 because it gives me the first occurrence. It's just basically as soon as it finds this A, it gives me 0. It doesn't even notice that there's a second A in ABBA. And then lastly, what index of does is if you look for something that's not inside of the string, it's going to give you a -1. So for example, if I look for Monroe inside of Saline, I'm going to get a -1. If I look for Z inside of Saline, I'm going to get a -1. Why? Because there's no Z, there's no Monroe inside of Saline. Now, in these examples, I used them on a bunch of string literals. I'll show you how you can use them with variables here inside of code.hs. Let me switch over. Index of. So examples with index of, let's say I do, let's say I look for lake inside of Blake, for example. I could do index of lake. I can make a variable to store the result. And I could do the place that Blake is located first. That's the name of the string, the object. Object dot method is index of. And remember, index of requires a string that you're looking for. I want to find lake. So I could do lake like that. And then if I print out, oops, sorry, there we go. If I print it out like that, you'll see that lake, the index of lake inside of Blake is 1 because the L is at location 1 inside of Blake. So that's index of, oh, here's a good one. What if I search for, look at that line of code. Ain't that a beaut? Line 20 there. If I look for first inside of first, basically it's saying, where is there a Blake inside of Blake? Yes, Blake is inside of Blake. It starts at index 0. So we see that there. And that's index of. And again, if I look for something that's not inside of the string, you know, if I do something else like, oh, let's say first dot index of Z, there's no Z's in Blake. Trust me, I've been writing the name my entire life. You get a -1 because it's not in there. Any questions on index of or any other examples you'd like to see on index of? Oh, baby. Okay. All right. Let's keep cruising here. I've got 2 more I want to get to in the next 3 minutes. Will I do it? Stay tuned. The next one is called equals. I don't think they have you use equals that much, but let me explain what it does. The way that equals works is it compares 2 strings for equality down to the capitalization, making sure they're exactly equal. Each character is in the same spot as you go across the string there. It has to be the exact same, including the capitalization. Okay, so you call equals, and it actually returns a Boolean, meaning it returns a true or a false value. If you remember, I think they talked about Booleans a little bit in section 1, unit 1, and then a little bit more here in unit 2 as well. So, so the way it works is you put a string in the parentheses, and it gives you a true if they're exactly the same. It gives you a false if they're different. So here's an example. If I, excuse me, I may have messed up my example here. If I have a string city that contains Saline, and then maybe I make a Boolean variable called is it saline? We'll find out. If I do city dot equals saline, again, the name of the object, city dot the name of the method equals, and then parentheses what I want to compare for equality. It's basically saying is saline equal to whatever's inside of city. They are, so it returns true. If I did, you know, maybe I print out city dot equals Ann Arbor. Well, right now city contains saline. I believe saline and Ann Arbor are a different set of characters, so this would be false. So it just gives you a Boolean. I don't think we really have a way to use Booleans right now, so just know that it gives you a true or a false value. And so it's for comparing two strings. Let's do an example in code.hs real quick here. Equals. Sorry, I'm trying to get out at 3.2. I just want to, just making sure I'm being totally, if I promise half an hour and I go over, I apologize. So I will have some time at the end to ask questions if you have them. So don't leave if you got questions. But so if I do something like Boolean, is it Blake, for example, I could do first dot equals Blake. And then if I try to print out is it Blake, remember Boolean variables can only have one of two values, true or false. Let's see, is Blake equal to Blake? It is, so I get a true. If I just have the capitalization different a little bit, it's going to find that they're different and say false in that case. So yeah, remember this could be where I have first here, that could be a variable name like I have now. It could be a string literal inside of quotation marks. Same with what I've got over here. This could be Blake and, you know, it could be a string literal inside of quotes. It could also be a variable. That's equals. I don't really know what they have you do with it, but it is there. Okay, we've come to the most confusing one. I apologize, but I want to make sure you kind of understand. They have a long activity that walks you through it. It's called compare to. Compare to expects some other string in parentheses, kind of similar to equals, kind of similar to index of. So what compare to does is it gives you back an integer, a numeric value, that compares the value of the first character that is not equal in both strings. So what the heck do I mean by that? Well, here's an example. Let's say I do Blake dot compare to Foster. What's the first difference in both of these strings? Well, it starts at the first character, B in Blake and F in Foster. Those are different. So Java immediately stops and says, oh, I found a difference, or compare to immediately stops and says, I found a difference. And essentially, it does subtraction of those characters. So it would be like B minus F. Now you're looking at that and you're going, I can't subtract strings from each other. And you're right. But basically strings in the characters in the computer's memory are actually numbers. We know computers deal with numbers way better than they deal with letters, feelings, emotions, all that stuff. And so essentially every character has its own numeric code in something called an ASCII table. Now, I just put this on and some of you are freaking out maybe. You don't have to memorize this. I'm just kind of trying to show you what an ASCII table looks like, what characters look like in the computer's memory. And I think code.hs talks about this a little bit as well. For example, the B that we saw has a numeric value of 66 in the computer's memory. The F that we looked at has a numeric value of 70 in the computer's memory. So basically the operation, and pardon my handwriting, I don't have a mouse right now. B ends up being B minus F. What's B? B is 66 in this ASCII table. This is what the computer does. Don't act like you have to do this. You do not have to do this. Computer does it for you. F is worth 70. And so we end up essentially getting a -4 as the result there. Now, that's a little confusing. I'll be the first one to say it. B minus F is -4. Now, if I switch these, let's say I did Foster.compare to Blake. Now, in this case, it looks at this string and finds the first difference. The first difference is F and B. It does change the value. You're always taking the first difference from this string, which is F, and subtracting from it the first difference from this other string, which is B. You might not think I'm doing a good job explaining it, but this is a confusing method. There's a whole long activity. You'll know compare to better than you know the back of your own hand by the time you're done with that activity. And it returns a numeric value based, because character values are actually numerical values. And so I showed you that ASCII table. Here's what you need to know. Essentially, pretend like you've got the alphabet lined up in front of you from A is over here, Z is over here. A is going to have a smaller numeric value, like it's on the number line, than Z, because Z comes later. So A dot compared to Z, A has a smaller value than Z, it's going to be some negative number. If I do Z dot compared to A, Z is right on the number line, Z is later in the alphabet, so that would be some positive number. What I want to clarify here is that you don't need to know, you don't need to calculate the exact number. All you really need to know with compare to is if something is going to be negative, going to be positive, or if they're the exact same from the beginning to the end, you just get 0. So I put in a couple more examples down here. 9.compare, so this is basically the order that it goes in. You don't have to have that memorized, but it does spaces, then numbers, then capital letters, then lowercase letters. I usually tell my AP kids single, space, number, capitalized, lowercase is the order that stuff goes on. And obviously in the capitalized and lowercase it goes A to Z. It's complicated. Let's so I've got some examples down here. Since 9 comes to the left essentially of A, it would be some negative number. Doesn't matter what the exact value is. Since A comes to the right of 9, I would get some positive number. If I do A dot compared to A, they're the exact same string, so I would get 0 in that case. Now, if I do something like ABC dot compared to ABZ, where is the first difference? Well, the first character, or the one at index 0, like we talked about earlier, 0, 0, they're the same. So then we move on to the next character, B and B. They're the same. Elements and corresponding indices are the same, so it keeps going. And then we see C and Z. The first difference is that C and Z. So essentially it does this C minus Z. Since C is to the left on the number line compared to Z, something smaller minus something bigger is going to be some negative number. And again, after saying all that, the exact value is not important. Really all that matters is you understand if it's going to be positive, negative, or 0 if they're the exact same. Let's do an example of that. I bet you guys want to see an example because it's like super confusing. Let me do compare to down here. Give me some room, please, CodeHS. Okay, so if I do, let me put all these inside print statements. If I do Blake dot compare to, I don't know, first, for example, which contains Blake. What's that going to be? Well, they're the exact same. I expect to see a 0. There's our 0. Let's say I do something like first dot compare to Z. Well, what's the first difference between Blake and Z? I would say Blake starts with a capital B. That's what's inside of first. And then Z starts with a Z. That's the only character. That's the first difference. So it's going to be B minus Z. B, as far as I understand, comes left in the alphabet, so it's going to have a smaller value than Z. Something smaller minus something bigger gives us some negative number. You do not need to know what that exact value is as long as you understand it's some negative number there. You probably could have done the math in your head because you know there's 26 letters, you fancy pants. Let's do one more example. Let's say I do, let's do first, which contains Blake, dot compare to, oh, let's see, how about Blade, there we go, that's what I was gonna say. Now, what's the first difference? Well, first contains Blake. The first difference would be the K in Blake and the D in Blade. So it's going to be K from first, the first object here, K minus D. K is to the right in the alphabet of D, so K will have a bigger value. So K minus D should be some positive number. You don't need to know the exact value, but you could do D, E, F, G, H, I, J, K. Whoa, 7. That's where it comes from. Wild stuff. The big idea is you don't need to know the exact value. Okay, I took 10 minutes longer than I planned on lecturing for. I'm sorry. Thank you for paying attention. Pinch yourself. Make sure you're still awake and alive. Check your pulse. Hopefully everything's cool there. If you want to hang around, you can hang around. I'll take requests for the next 20 minutes until 3:30. If you're good, then good luck on doing the string activities for this week. I've got time Tuesday and Thursday that you can schedule as well if you haven't looked at it yet. And I'll have open time on Wednesday as well to go over the math class, the second lesson from this week. So if you're taking off, adios. If you're hanging around, you got a request, you can put inside a chat and I'll check it out. Otherwise, see you. You're very welcome. I'm just responding to chat. That's why I said you're very welcome. Somebody said thank you.